last week for you guys. He's going to cover inheritance. So inheritance will be a topic that you'll get to see in 136. So it's just the next class you will see it. And this is Donnie Cordova.
Yes.
And Donnie is interviewing with us for a job, a full-time job, much like Sherry and ours. And Sherry told me that we're both come up here. We haven't had a search like this for, I don't know, over 10-something years, a dozen years. So the first one. What's that?
So this is an intense interview.
No pressure.
So yeah, we're just gonna go ahead and start and pay attention.
Go ahead. Thanks, Mom. All right. Well, thank you. Thank you for having me. Again, my name is Donnie Cordova, and since we're a small class today, I wondered if I could get maybe your name, and then I'll also tell you a little bit more about myself, but maybe just share your name and how long you've been in Oregon, or where you're from, if you're not from Oregon. How about we start here?
I'm Wyatt McKeever, and I was born in
Okay.
Oregon.
Oregonian. How about you, sir?
Nick, I was actually born in Portland, Providence, so I've been in Portland all my life.
Okay, very cool. How about in the back there?
My name is Issa. I just moved to Oregon 4 months ago.
4 months. Okay.
Yeah, neighbor of yours, Arizona.
Arizona. Okay. Very cool. How about you, sir?
I'm Ben. I've been here my entire life.
Nice.
I'm Brian. I've lived in Oregon my entire life as well.
Okay.
I'm Alex. I've been here about like 8 years.
Okay. Where did you live before? If I may ask.
Kind of moving around from California and Nevada, so just kind of like the same general West Coast area.
Landed here. Good. Awesome. Well, I am not from here. It took me a while to get used to the rain, but I like the rain now. I'm originally from New Mexico. I graduated from University of New Mexico in Albuquerque, so we had pretty much no rain. And we did have snow in the winter though, so it made for quite a bit of bad drivers. So, after that, I took during my undergrad, I had internships with the Hewlett Packard at Fort Collins, and so I got summers up in Fort Collins, which was nicer and greener for me. Still love New Mexico, but I like the green, so that's what drove me to want to move to Oregon is the green. So that took me after my undergrad to Idaho. So I lived in Idaho, worked for HP for several years, moved here, transferred here, got to work in Corvallis and in Vancouver at HP. And then I got to work at some startups in Portland. So it's just a great area to be for jobs, for green, for range, for everything. So I can see why a lot of you that have born here, why you're still here. In New Mexico, we just like, what first chance to get out? Anyhow. So my contact information, should you need it, my permanent email address is dcordova@cs.unm.edu. Like if at the end of our lecture you want to get in contact with me to talk about anything really, my perspective on jobs or companies around here, I know quite a bit, know a lot of people that made a lot of friends, I guess. So I kind of know people everywhere. Feel free to shoot me a line. Oops. So what I plan to do today is, thanks for the introductions. I'll talk a little bit more about myself here in a minute, but what I want to cover, what we're going to be covering is inheritance. And like Fung said, it's something that you're going to be doing in your next class, so it's hard to cover it in that 45-minute time frame, but I'm going to give you at least a glimpse of what inheritance is, kind of with the power that you can do with it, and then kind of let you run with that. And either you might want to take it and go and look at it some more, maybe try some code out, or you might wait till your next class and then it'll be a refresher. So we'll talk about what is inheritance, why I think it's important, how do we implement it in C++, because there's different ways and different languages to implement it. So I'll be focusing on C++. They're very similar. The C language of the C family of languages like C, C#, Java are all very similar as far as implementing it, but with C++ there's a little bit of things you need to know. So we'll touch a little bit on polymorphism from the perspective of inheritance. That's another big topic, as these guys, as Sherry and
We mentioned that too.
Oh, you have? Okay.
Yeah.
So that's
But
another.
just so that we know you're coming, so I.
Okay, good.
So, yeah, nothing in detail.
Okay, so we'll review inheritance then. And then we'll have some time at the end for questions, although I do recommend if you have a question, just let me know. We'll answer it right away so you don't forget your question or you don't let me off the hook for anything. Sound good? All right. So just a little bit more about me, aside from not liking New Mexico and really loving Oregon, is that I'm a professor of computer science at another school. I teach primarily programming, data structures, teach a lot of Android development classes or mobile development classes, some database if I didn't already say that. My primary role, I teach and I also work as a full-time software engineer. So I do that during, I guess, day hours. So I work at a company called Safe Corporation down in Salem. We work on workers' compensation for Oregon and surrounding states. I get to work on data exchange. So taking data from some formats to other formats and making sure it gets reported to regulatory agencies. So it's kind of a fun data workflow if you're into data transfers and into networking. It gets into all those pieces. My academic background's in computer science. As I mentioned, from University of New Mexico, I have a degree in computer science, and I have a degree from Rochester Institute of Technology in software development. And I also had a focus on management. And my experience in the industry has primarily been in software development, though I did have project manager, program manager roles along the way. I guess they wanted that feeling of power, maybe. Control, right? Being able to control your destiny. Sometimes it's hard when you're just a developer, but sometimes you have opportunities to be able to shape it a little bit more. So it's just an opportunity to try if it's something that interests you. So I've kind of been around the block in terms of development there, environments. I've done most of my time in C++ and Java, C# more recently, a lot of web development like ASP, HTML, CSS, and more recently got into Android development, a little bit of iOS development. And in my time at Portland, we were really focusing on Ruby on Rails. Has anybody heard of Ruby on Rails? Yeah. And have you dabbled in it at all?
Not the on Rails part.
Yeah.
Like I did a
Ruby.
little bit of Ruby.
Okay.
Just to kind of see what it was about.
Yeah. Yeah, so it's a fun language that you can get something going pretty quickly, and then with the on Rails part, build a web application. There are, of course, drawbacks to be able to do something very fast, right? You get drawbacks in performance and things like that, but that's for a separate discussion. So any questions about me or where I come from? Anything about where I've done and what I've done? Good. So what is, when you hear inheritance, what do you think about?
Money.
Money, yes. I like money too.
Gold.
Gold.
Taking some from the parents.
Taking something from your parents, yes. Yeah, these are good things that involve inheritance, right? You are getting money from somewhere, or somebody's giving you a house, or in my case, they're taking away your house that they gave me. My dad disinherited my house because he wants back. My childhood home because he knows I'm not going to go back, so he took it back. But so the hound was the other way, right? Pulling it back. But yeah, so that's what people think about when they talk about inheritance. There's also the biological inheritance, right? Where you can think about you have a mom and you have a dad. You get traits from both, and there's you. You get your traits from both your mom, your dad, and your ancestors. So it's a different type of inheritance, right? So that's where actually programming inheritance borrows the concept of inheritance from, is being able to inherit from your parent. So very similar to biological inheritance. So inheritance is a concept, falls into what I consider the four pillars of object-oriented programming, any object-oriented programming language, which is abstraction, encapsulation, inheritance, and then polymorphism. And these two is what we'll be focusing on today. But as you've been coming across your classes, have you focused on abstraction, understanding abstraction, and encapsulation? Yeah. So I heard that you guys were working on classes, so that gets you really, really primed to be able to jump into these more advanced features like inheritance. Because once you can understand classes and how to abstract data functionality, then you could use the power of things like inheritance to make your code very reusable. So inheritance as a software engineering definition is that you can, it allows you, it gives you the power to be able to derive a new class from an existing class, okay? So some terminology here, the existing class, we call it the parent. In some other languages or some other context, they'll call it super, your super, or base class. So base class is primarily what I call it, or the parent. So parent-child is easy to remember based on the biological definition. And the derived class then is the child or the derived. So I go back and forth, and it depends on your textbook. They'll call it one or the other. Do they call it derived, Fong?
Parents and
Parent,
child,
child.
I think.
Yeah.
Our textbook here does not go beyond just classes, the abstraction and encapsulation.
Okay.
These things, so we have 3 classes. We have C++ programming 1 and C++ programming 2. So these guys are in programming 2.
Uh-huh.
So the text they're in doesn't have inheritance or polymorphism.
Okay.
But they have been introduced to it.
Okay.
Yeah. So we tend to use this text, which was written by 2 of our colleagues.
Okay.
Down in Klamath Falls.
Yeah.
And so it was written specifically for these 2 classes, and these 2 classes ends at linked list. So they write classes and then they deal with pointers, and then they'll go to linked list. But so the next class 136, and then we just go straight to object oriented, and these things will. So they're interested in the sense that they have to do this next.
Yeah. Okay.
And it's kind of completely different.
Got it. Okay. Well, very good. So we have this cool relationship that we've just talked about. So let's talk about the behavior that you get out of inheritance, right? So the child then can inherit those characteristics from the parent that it chooses to take advantage of, okay? The child then has what we call special rights or special access to that data or to those characteristics, to the data or the behaviors. And the child can then, it could create some of its own unique behaviors or unique data, or it could just use the parents, just be one of those ones that doesn't move out of the house, right? It's not going to define itself. It's going to just use its parents' information and data. So you can do a lot of cool things with that. One reason that I think that it is very important, and I'm going to skip just one slide here, is that it allows you to reuse code. Okay, so I'm lazy. I want to write something, and I want to write it once if I can get away with it. Why would I want to do that? Why would I want to avoid writing multiple pieces of code that essentially do the same thing? Yeah, more code to have to worry about maintaining, right? So reuse is awesome if you can. If you can manage to write code that's reusable, then it's less maintenance, less having to worry about bugs. If you fix a bug in one place, you don't have to fix it in another. It's just the same code. So that's where inheritance kind of is really powerful. So let's go back to the behaviors here. So a little bit more on the behaviors. Do you guys remember UML, or did you look at UML a little bit when you were designing your classes? So in terms of inheritance, this is what inheritance relationships look like. This is just a single level, so just one child. So this isn't the UML diagram, but just showing blocks to show the relationships here. So a bird is an animal. That's the terminology we use with inheritance, is a. Okay, so a bird is an animal. So it creates that relationship, and really what we're saying is that a bird is a more specific version of its parent, which is an animal in this case. So just a simple concept with an animal and a bird. Does that make sense? So what types of things do, if we were to subclass an animal a little bit more, okay, what would be, like say we were going to put a dog also underneath an animal. So we have an animal just like we're showing there. Okay. And then we have a bird. Actually, let's make this a little bit easier, right? Because birds are a species that are a little harder to relate to stuff we have at home. How about we do a cat and a dog? right? Just put my arrows here. What types of things do cats and dogs have in common?
4 legs.
They have 4 legs, yeah. What else? So number of legs. What other data members might they have in common?
Tail,
They have tail, sure.
usually.
Sorry? Usually, yeah, I was gonna say my dogs don't, I have some Yorkies, they don't have much of a tail. It's like a stub. How about as far as behaviors, what do all animals do? What does a dog and a cat do that is similar? They eat. Yeah, very well. Anything else you can think of? We'll get into a lot more examples like this, but I just wanted to get us thinking about inheritance and relationships. What else do they do? Maybe walk? Yeah.
They shed.
They shed, yes, that's in my house.
My sons.
But they do some naughty stuff too sometimes on the carpet, right? Mine do anyway. So that's it's as simple as it gets. You can have a subclass that defines some of these common things, and you can make more specializations down here in this cat and in this dog class, such as maybe the noise they make, right? Maybe you want it, maybe you want to represent the cat's noise to be meow versus the dog's noise to be bark or woof, right? But all the main things they have in common are in here, so I don't have to code them here or here. It makes it that easy. It makes it easier for me to be lazy. I want to be a lazy developer that doesn't create code that I don't have to maintain. Any questions so far? Maybe a little fast. So again, it's important because you can make yourself lazy, which is great in my book. Not lazy on your code quality, but just on the amount of code you're outputting, because it's a nightmare to have to maintain a lot of code that you could have that's duplicated code essentially. So here's a little bit more complicated example of inheritance here. So here we have the animal again, and then under animal we have subclasses for a wild animal and then domestic animals. Okay, so on the domestic side we have stuff like we have at home, like our cats, our dogs, and horses. I don't have a horse, but I hear some people do. Okay, on the wild animal side, tigers, lions, and bears. And the point here is that this is a hierarchy, and a tiger is a wild animal. It's also an animal, okay? Also like a bear is a wild animal. So is a lion a domestic animal in this hierarchy? No, but it is an animal. That's what they share in common. They're all animals, okay? The key thing from here I want you to take away is the is-a relationship. This is very important in inheritance because when you try to later look at these objects and substitute them with other objects that are like them, you have to know whether it is that same object or not, whether it is a descendant of that object that you want to substitute. Okay? Sorry, I don't mean to just keep looking at you here. I'm trying to go this way too because there's a camera there, so I try not to look at it. So here's just a couple more examples of inheritance. These are ones you'll find in textbooks or online, very common ones. You might have a student-based class, and you might subclass it with the different types of students, like an online student or an on-campus student, resident student. Shapes is another big one that, shapes, I think, in loans or counts are the 30, 40-year-old examples, but they're good, right? Because you can subclass a shape. With a shape, you can have circles, triangles, and rectangles. What do they have in common, though? What would be in the shape class?
We just kind of
Is it one
gave an
eight?
example of that.
Yeah.
On polymorphism, this is a classic shape circle. Where's the center of a circle? Center
Oh, yeah.
of a triangle, center of a rectangle.
Right.
So we just quickly we're going to look at some code.
Okay, very good. Same thing with the loan. You might have the loan characteristics or data up here that says who's the loan belong to, how much the interest rate is. But at the individual level, down at the car loan or home improvement loan, you're going to have different ways of calculating the interest, right? That's where you can break off and create some unique code that may not necessarily be part of the loan class. So these are more of my favorite ones here, at least the bottom ones. We have gamers here. little bit, few. So if we were going to create an enemy class that had some subclasses, like maybe that's where I'm not too creative, but like a ninja or an ogre or an assassin, what types of things might they have in common, these enemies?
They'll attack.
What's that?
They all attack.
They all attack, right? So their behavior would be attack. And their attack method would be different, right? How does a ninja attack?
Quicker strikes.
Like maybe a judo chop or something, right? Versus how does an ogre attack?
Big smash.
Like a smash, or they bite you, right? They eat you. Or an assassin is primarily just going to try to shoot you, maybe, right? And how about on the lighter side, the superhero? What would be our behavior for a superhero that they all share but do differently?
Costumes.
Their costumes? They wear costumes, sure. So instead of attack, although they do attack to protect themselves, maybe protect, right, or defend. So those are the types of, that might be the type of special code that each of these writes for themselves that's not part of the parent, because they all do it differently. They all have their own superpower, right? So let's look at the animal again. When we talk about inheritance, there's one thing I need to introduce you to a little bit, and I don't know if you got into this when you looked at this last time. Okay, it's a new keyword for you. So you've looked at classes, you've talked about private and public and private modifiers or access specifiers. So for inheritance, we have another one that we're introducing called protected. Okay, so protected will get defined just like your privates and your publics. So everything between where you declare protected and then your next access specifier is going to be protected. So what does protected mean? Well, protected means that to the outside world, it's private, but to your children, it's public. Okay, so that's what protected means. So if I have some data members that I want my children to be able to access themselves, then we would make those protected. The better way, in my opinion, to do that is instead of doing that, you could just create accessor methods. Did we talk about accessor methods? Okay, so your getters and your setters. So it's almost always a better way to expose the type of data you want exposed rather than blanketly putting protected on there. But protected's there for us to be able to do that easily. Okay. So if we look at this example, we've got an animal, and I looked at your coding standards and noticed that you have to have a C in front of them, so I put C's there. And the way you declare that you are subclassing or you're creating a child of is you use, after your class name, you use a colon. And then for public inheritance, we'll talk about the different types of inheritance, but for public inheritance, then you put your class name. So this is my child class, and this is how I'm subclassing it. Okay. So so dog is an animal. So based on what I just said about access from the outside, like from your main class, does something in main have access to an animal's private data members? See if we can decipher this table together. No? So that's based on what you learned before, right? Anything that's in private, you can't access from outside the class. How about the protected members? So if I declare a dog inside here, can I access its protected members? No, right? The only place I can access protected members is within the class itself or in its children. Okay, so any protected members here, I can access them here inside the dog. Any questions on this? So I mentioned there are different types of inheritance. Earlier I had a colon public A, and this is where I broke the coding standard because putting a C in front of A, it made it very confusing, right? So instead of CA, it's just A. But if I declare public inheritance, which is the most used inheritance when you're actually coding, we have the behavior that we just talked about. But let's look at protected inheritance. If you use a protected inheritance, then when you talk about X, Y, and Z, which X is public, Y is protected, and Z is private, then the key thing for a protected relationship here is that X is protected, okay? It was public in class A, but from C, it's going to be protected now. Y is protected. It was already protected, but it's going to maintain its protected status. Okay, so only itself can access it or its children if it has any. And then Z is not accessible because it's private. It remains private. You can't change it to public. And then same thing with the private here. It just makes all of your elements that were public up here, makes them now all private. Okay? Do you have a question? No? Okay. So let's take a look at an example here. So what if we were told that we need to develop an inheritance hierarchy for social media? Okay, we want to have a generic user, social media user account, and then under it, we want to have multiple different types of social media accounts. Okay, for example, we want to have a Facebooker, a Snapchatter, a Tweeter, right? But we want to put all of the common characteristics up in the base class, but each of them might have different functionality. What might they do differently? Any ideas? Yeah, the posting is definitely different between them. So what's Snapchat's requirements, or what is their deal?
Just like a picture.
Yeah, so it's only a picture and then it's gone within a certain number of seconds, right? How about how about Twitter?
Certain number of characters.
Yeah. How many? Let's see if I remember. 140 maybe? So 140, I think, and otherwise you can't post, right? At the beginning you could post, but it would just chop off. So we'll probably do something like that since we don't have much time, but we'll remember to keep that requirement in mind. And Facebook, I'm not sure what's special about Facebook. It's you can post whatever you want essentially, right? And it lines up on your, they still call it the wall? Your wall? Okay. So let's take this approach here. Let's develop a class called CUser, and then let's take the Twitter and the Snapchat as two classes that we're going to subclass. Okay, I'm going to sit down for a second here to pull up Visual Studio. Actually, before that, this is what the class diagram might look like, or will look like after we're done implementing it. So we'll have our user. I'm going to put just some brief information in the base class, the first name, last name, and then notice here I'm going to have a post function. Okay, my child classes, which is the Tweeter and the Snapchatter, they have that relationship. They are a user. The Tweeter has a special data member that the others don't have, right? A handle. So your @ and then whatever your name is, or whatever your user account is. Snapchatter, I couldn't think of, I don't use Snapchat, so I just hear the kids use it, right? I don't have kids, but the kids, or some people use Snapchat. So I don't know if they have any specific handles. They probably do. They probably have some, maybe you could change the timer. I don't know. Probably, I don't know. Good questions, right? So we're going to implement that hierarchy here. And then note here that we have the opportunity, because we're subclassing, to actually override the post method or function. So because we're children of user, we can use user's post function or override and create our own. And that's where we want to take advantage of inheritance, right? Because they all do posts differently. So let's do that. The second thing we're going to do after we create the inheritance model is we're going to actually create a batch process of sorts that's going to take multiples of these accounts and then post or call their post functions. And we want their individual post functions to be called. So just keep that in mind. So since we didn't have too much time, I coded up the classes here. We'll implement the actual batch process together. But let's take a look at our user class here. So we have protected members here, and I know I said don't do this, but I'm just doing it for an example. This is how the protected members would look if you structure them that way. So they're under my protected keywords, my first and last name. I've got my default constructor. I've got my constructor overload that takes two parameters, just the first name and last name for when you instantiate your user. And then here's my post method or function. My post function takes a string. So this might not work for Snapchat if it only takes an image, but we'll pretend that it does for now. But it just takes a string and it posts it to the social media network. Okay. Now let's take a look at let's look at the tweeter.h file here. So this one, we have a handle. Notice I made it private because it only has to do with Twitter. It's not something that that other social accounts need access to, right? So I'm going to put it in the private space. The issue might happen though is if I tried to subclass Tweeter, I would have to put some accessor methods to be able to get access to the handler if I needed it. Otherwise, we have to put it in protected. So my Tweeter, it takes as a parameterized constructor 3 strings, okay? First name, last name, and then the handle. We've got a deconstructor, and then we have our post function. So our post function is the same as the base class, as far as the definition goes. It just takes a string and that's what it outputs, okay? And then our Snapchatter, very similar as well, just has a 2-parameter constructor. We have our deconstructor, and then we have our post method. Any questions on that? Now let's look at the implementations. So the user, it has a very simple constructor here. It takes the first and last. It calls the default constructor, which is right above it. It doesn't do anything, but it's calling it right now. I have a cout statement here that I can uncomment, but just wanted to show that you can have it call your default constructor as well, if you'd like. And then there's my deconstructor, doesn't do anything useful. But here's my post, okay? My post, basically I'm just saying this is the base class post function, and then here's the message that you wanted me to post. So very simple. So if we go to Snapchat, let's go to Twitter first. So on the Twitter side, it takes the first, the last, and the handle in the constructor. I'm passing into the parent constructor the first and last, right? Because that's where I have my first and last. That's where those live. So I'm passing them to my parent constructor to set. And then I'm setting my handle. So this is just a fancy way of being able to set them inside without having to put them inside of your constructor definition, right? So I'm setting them here inline instead of doing, I could do it in here as well, which you might have been doing. But I chose to use this method just to keep it clean, okay? My deconstructor doesn't do anything, but my post does. So here on my post, what I'm doing is I'm checking to see if it is greater than 140 characters. Do we know our ternary operator? Have we studied that yet? No. So basically what line 20 here is doing is it's a one-liner if statement. And remember, like I said, I'm lazy, less code, right? So just quickly, because it's something that I found when I was in school, found fascinating and never stopped using it since. So basically what this is saying here, do you see how I'm setting my string equal to something? So the equivalent of a if statement that's doing the same thing is, what did I call it, final post? The equivalent is to check a condition. Here I'm checking this logic here, is the length of my string greater than 140? So I would put that in my if statement. Right? If it is, then final post is going to be equal to, and what I'm doing with the final post is taking the substring. I'm saying post dot substring, and you pass in. It's a multi function. It's an overridden function that you can call with different parameters. But the one I'm calling, it takes 2 parameters, the start and the end. Okay, so I'm going to say I want from the 0th character to the 140th character, I want that returned, and I want to store that here. Otherwise, final post is going to be equal to just post. Does that make sense? How it converts to, but kind of cool how you can do it in one line. I don't know if you can see the rest of the line there. But basically, this is the condition. This is the question you're asking. If the question is true, then you're going to do this right here. If it's false, it's delimited by a colon, then you do the second part. Okay? All right. So all we're doing then after is we are posting that tweet out to standard out for, in this case. When we get to our next version, we would actually maybe be using the Twitter handle or the Twitter API or something. But this is just for starters. And then Snapchat are very similar, except its post, it doesn't have any character issues. It actually should be taking a picture, but here we're posting a Snapchat. Now you see it, now you don't, right? How to simulate disappearing. All right. So do we understand the inheritance hierarchy of our social media little game here? Yeah. Now let's fulfill the requirement that we talked about, where we're going to do a batch process to create multiple of these guys and then post the same message to all of them. So before we do that, I'd like to just talk briefly about let's create some of these guys while we're here. Let's go into I've created a social media which has my .cpp that has my main class. So I'm going to create. We're comfortable with raw pointers. I won't get attacked if I use a raw pointer. Okay. Do we teach smart pointers at some point?
Not in
Okay.
the freshman level, no. We have a 400 level class that we do smart pointers.
Okay. I taught raw pointers and then I taught smart pointers, and my students were mad. Why didn't you teach us the smart pointers? Because after all the struggles, because you have to struggle with them, otherwise you won't learn. So we're going to use raw pointers today. So I could create a generic user here. I'm going to create a pointer to a user, and I'm going to instantiate it as myself. Okay. I could also create a Twitter account the same way. Except this one I'm going to make for one of those Yorkies without a tail, my dog Spaghetti. And I always forget my star here. And same thing with the Snapchat. So you see I can create an instance of any type of object I want. Okay, let's create a Snapchat one as well. And my other dog is Frida, named after Frida Kahlo, in case you know who that is. Who is it? Who is it? She is an artist. So what's wrong with my? It's an artist. What's wrong with my line number 9 here? So it says none of the overloads except 2 arguments. Okay. Remember, my Twitter constructor takes 3 because I need a handle. So that's why it's complaining. Typically, what's that?
He said it down here.
Oh, it did? Oh, sorry, I didn't hear you. I hear the fan for the smart projector.
I can hear you.
All right. Okay, so now let's make these guys post. Okay, let's say user post, and let's post a message. How about the tweeter? Let's make Spaghetti say woof. And then Frida, she's pretty quiet, but we'll get her to bark. Oops, she's a Snapchatter though. And let's run this guy and see what it does. So which, if I call user, what do we think it's going to print as far as post? Is it going to use the base class? Yep, function, okay, because it is a user. How about the tweeter? Which post is it going to use? Any ideas? We're getting into the point of talking about polymorphism, but I just wanted to see what you thought. So it will actually call its post function. And same thing with the Snapchatter, it'll call its post function. Let's run this and see that I'm not telling you otherwise. So there's there's the post from the base class. The second one here from Spaghetti, she's posting a tweet. And then the Snapchat post, posting the bark, okay? Now, we still have that problem though of needing to post the same message to 3 users, okay? Say myself and my dogs, we all want to post the same message to all our user accounts at the same time. So that's where we're gonna get a little bit into polymorphism. So what polymorphism means as far as a definition goes is it is of many forms. Okay, you talked about polymorphism a little bit, but what it basically allows me to do is to call a member function from a, it allows me to call the member function from whatever class that I'm actually instantiated as, okay? So what that means is I could create a user, I could declare one and instantiate it as a tweeter. And then I could tell the compiler how I want it to behave, whether I want it to post its own, using its own post method or its parents, okay? That brings up another quick little keyword we're gonna have to learn, virtual. This is all accomplished by using virtual functions in C++. So basically what this does is it, when you declare a function in your base class as virtual, what happens is the compiler goes and creates a little virtual table that says this is where this function's mapped to. This is where this version of that is mapped to. Okay, so you get a little bit of an overhead in your compile and in your run with the virtual table. And I bring that up because in my experience in the past, we had to worry about how much memory we were creating in a module that was processing image data for a printer. And the overhead of having virtual functions was actually too much because we had a lot of image data going through. So just knowing that, we'll read hopefully something later. Oh, we have to, if you're memory conscious about something, hopefully you'll remember that there's a little bit of an overhead time-wise and also memory-wise for using virtual functions, but they're powerful, okay? So what that does, if you declare a function virtual, is it invokes dynamic binding. So what dynamic binding is it tells the compiler that at runtime, we will determine at runtime which function will be called. Dynamic binding is opposed to static binding, meaning when you first compile, you'll get the mapping drawn up right away and it won't change during runtime. So let's go and create that batch process here. So I'm going to create a user array. I'm going to call it batch. And I'm going to make it of size 3 because I have 3 accounts, right? And I'm going to do lazy instantiation of just instantiating it with my instances that I've already created, my dogs and myself. So the way you do that is you can just put them in between 2 curly braces. So I'm going to put my user, my tweeter, and my Snapchatter, or my Snapchat. So there's my array. And notice it's of type C user, even though my tweeter and my Snapchatter are actually Snapchatters and tweeters, okay? Now what I could do is I could run a for loop. I'm just going to say less than 3 because I know there's 3 things in there, okay? And then I'm going to call my post method on each of these. So batch sub I, arrow post, and I'm going to post the same message here. Hello from the Cordovas, or from the Cordova family, okay? So what do we think is going to happen? Which function is going to be called? Which post function?
The post function from each, like their own.
Their own post? Let's take a look. They're all going to call the parents. And that's because we didn't go and make our base class virtual. Once we do that, then the compiler will do dynamic binding and it'll call the actual function that is binded to that instance. Okay, so let's go into our C user, just a quick change. I'll put virtual here, and let's run it again. So now it's using the functions from those specific classes. So all I do is run the same array, run the array through, call its post function, and then it calls the appropriate post function. So pretty cool, right? Yeah. I know Fawn's saying yes. Well, it's just cool stuff altogether. All right, any questions on how we've on what we've covered so far?
Can you go
Just some
back real
closing
quick?
words. Yeah,
Look at any one of those post function declarations.
yeah.
Please explain the word constant at the end there. So.
Oh, in my header file?
Just go down right there, line 22.
Yeah.
What does that mean?
You want me to explain or are you asking
Please,
them?
you-
Okay.
yeah.
So what this means is that this function will not change anything. Okay, it's constant, meaning it's going to be doing some stuff, but it won't be changing anything. If it does, give me a compile error. This helps me protect from myself, right? If I don't intend to change anything in this function, then I better put const here so that the compiler keeps me honest. So it's another kind of handy thing to do just to make your code more robust. And you don't, or a programmer doesn't come in after you and start changing things when the original purpose of it was not to change anything. It's just to post, not to change any data. Okay, well, I think I'm at my time, but if there's any questions, I'd be happy to answer. Yes, sir. Back.
What, you spent some time at HP and then moved around a bit. What languages did you primarily use?
So at HP, we were, so in my undergrad, we were also focused on C++, so that was my strength coming out of college. At HP, they threw me into Java initially. And then from Java, I went into C#. And then when I was writing, what I was saying earlier, those images that couldn't take up very much space, I was back in C++ again. So at HP, it was primarily those three languages. And then I got to learn Android development there. In Portland, the companies I worked for were very big on Ruby on Rails. Seems like that's pretty big in Portland, that people are getting things started up quickly with Ruby on Rails. And it's through, and there I also learned iOS development or Objective-C and more Android development. Also in Portland, I worked for a cloud company that did video transcoding. So it was kind of like I worked on images for a while at HP, or for a long while, and then moved on the video side, and we had to convert those images. Again, we had to be concerned with memory, so C++ was our language. On the front end, though, it was Ruby on Rails. So the interfaces to the actual applications were Ruby on Rails. Another question here? No? Oh,
I have
here.
a question.
Yeah.
about, like, your code.
Yeah.
So is there a reason when you instantiate your user, like your Snapchat or your video, is there a reason that you use a pointer instead of just calling the structure?
So I use pointers when I can. Again, it's that mentality that I want to allocate on the heap. Okay. Primarily from those days when I was a developer and we had to really, really care about memory. In those days, we were using have you guys learned arrays? A little bit. So we were using 7-dimensional arrays, so 7 brackets. And that's because we were converting CMYK or RGB images to CMYK, so we needed each of those different channels. And so they would do some very crazy neighborhood, how to calculate the red value to the whatever it calculates to in a CMYK. So that's why I use pointers just by default. But yes, you could do this without using pointers, just instantiating an object so it falls in the stack.
But down here, if you had if a batch were array of 3 of C user instead of C user pointer,
Yes.
will you still get the polymorphism?
So if I have a C, so it still is a pointer if you're using an array, right? If you're using an array of C user, you still actually have a pointer underneath because it's pointing to the object that you are trying to store in that array. So with arrays in C++, they behave like pointers anyway, under the hood. Did I answer your question? Or maybe I didn't answer, I don't understand your
Is
question.
it still
Okay.
polymorphism? Will it?
Oh.
Will it? Yeah. Will it?
Well,
So if I
polymorphism
could-
still works.
Still works. I mean, going into the so the array. So one is actually used. The other one is dog. The other one is. Will the post function of each come out when it's not a different pointer to different, like if it's an array.
If it's an array.
If it's a regular
Right.
static array instead of an array of pointers.
Right, and I think you need pointers for it to work. You need pointers for the polymorphism aspect to work, so that you can substitute a child for one of the base class or the parent class. So you can't get away from pointers, unfortunately, if you don't like pointers.
Yeah, you hear that? You hear that?
Pointers are good. That's why I love OIT's program that they have C++ in it, because I think it really makes really good developers. If you learn C++ first, you can take on anything and really appreciate memory and cleaning up after yourself, which you find people that learn Java first, or not that there's anything bad with what they do, but you can tell in code. Code speaks for itself.
Yeah, in our pointer section, we make sure we point, we kind of pound it in, like we want the array to grow just enough,
Right.
That's one of the reasons why memory management. And it just become it should just become a good habit.
Yeah, it'll become second nature just after a while. Once you get into your upper classmen, you'll be using them and won't even be thinking about it anymore. But yes, early on you might struggle with them.
Yeah, in this
And
class,
notice your ideas.
the first subject in this class, at the beginning of this quarter was pointers.
Was pointers. Good.
Yeah, and
So what's something I forgot to do? Speaking of pointers, I didn't destroy them, right? Bad.
There you go.
I was going to see if anybody would catch that. Yes, I didn't delete my memory. All right. Any other questions? If not, thank you so much for having me. Letting me crash your day before. Good luck on your finals.